Welcome to 3 Mile Island, the site of the most significant accident in the history of the American commercial nuclear power generating industry. On March 28, 1979, a series of mechanical and human errors led to a partial meltdown of the reactor core in Unit 2. To understand what happened, let's first look at how the reactor was constructed. The reactor at 3 Mile Island was a pressurized water reactor, PWR, one of the most common types used worldwide. It consisted of several key components. Reactor core. This is where the nuclear fuel, typically uranium dioxide, undergoes fission. The core is composed of fuel rods, control rods, and coolant. Control rods. These are made of materials that absorb neutrons and can be inserted or removed from the core to control the fission reaction. Primary coolant system. Water in this system is kept under high pressure to prevent it from boiling, even at high temperatures. This water circulates through the reactor core, absorbing heat. Steam generator. Heat from the primary coolant system is transferred to the secondary coolant system through the steam generator. This creates steam that drives the turbines, producing electricity. Containment building. A robust structure designed to contain any release of radioactive materials. The PWR design is intended to keep radioactive materials contained within the reactor and its associated systems, ensuring they do not escape into the environment. On the morning of March 28th, everything seemed normal until a minor malfunction occurred in the secondary system. The main feed water pumps stopped working, interrupting the flow of water to the steam generators. Without proper cooling, the temperature and pressure in the primary system began to rise rapidly. In response, the reactor automatically shut down by inserting control rods into the core. This was designed to stop the fission reaction and reduce heat production. However, shutting down the reactor doesn't stop all heat production immediately. The decay of radioactive materials continues to generate heat, known as decay heat. To manage this, the pressure relief valve opened to prevent the system from overpressurizing. But then, a critical failure occurred. The relief valve became stuck open, although the control room instruments indicated it was closed. This allowed coolant to escape, reducing the amount available to cool the reactor core. We faced a confusing situation. The instruments showed that the valve was closed, but it was actually stuck open. This led to a significant loss of coolant, exposing parts of the reactor core and causing them to overheat. As the coolant level dropped, we scrambled to understand the true nature of the problem. The core was overheating, and a partial meltdown was occurring. Our initial actions, based on incorrect information, weren't enough to stabilize the reactor. Over the next few hours, we worked tirelessly to restore cooling to the core. We injected emergency cooling water and tried to close the stuck valve. It was a race against time to prevent a full meltdown. The incident was a wake-up call for the nuclear industry. Although there was a minor release of radioactive gases, the containment building held, preventing a larger disaster. No injuries or deaths occurred as a direct result of the incident. The aftermath of the 3 Mile Island incident led to significant changes in nuclear plant operations, safety protocols, and regulatory oversight. The Nuclear Regulatory Commission, NRC, implemented new guidelines to improve reactor safety, operator training, and emergency response. The design of future reactors was also improved. Enhanced safety systems, better instrumentation, and more rigorous testing became standard practice. This incident taught us the importance of having accurate information and reliable equipment. It also highlighted the need for operators to be well-trained in emergency procedures. The 3 Mile Island incident remains a stark reminder of the potential dangers of nuclear power. It serves as a crucial case study for engineers, safety professionals, and policymakers worldwide. The lessons learned continue to shape the safe operation of nuclear plants today. And that was the 3 Mile Island incident.